My name is Damien Murphy. I'm a sales engineer here at Bitrise. And some of you already know Bitrise is a mobile-focused continuous integration and delivery platform. I've been building apps, enterprise mobile apps, cloud applications for over a decade. And today I'm going to share with you what I've been working on for the past few months here at Bitrise. There's a couple of things that I want to highlight before we start. So this is advanced Bitrise, so it's not for the faint-hearted. It's a work in progress, so a lot of what we're doing here is breaking new ground, and the steps I'm going to share and the code I'm going to share, this is all going to be shared through my own GitHub account. So we're still working on making all this official Bitrise steps, but you can leverage this in your workflows right now. And it will require multiple concurrencies to achieve a fan out greater than 1 or 2. So yeah, if you want to ask a question during the webinar, there is a little question mark. I'll actually just show you here. Yeah, so there's a little question mark down here, and you can click that. And when you type a question in, it will show up as a question, and then we can highlight those questions for you so that we can answer them easier. If you just want to chat, you can use the typical chat. Cool. So yeah, so without further ado, the reason that we're all here today is to talk about fan out builds. So the main driving reason that we wanted to do this was we wanted to find the fastest way to run iOS simulator tests without sacrificing stability and avoid any unexpected iOS simulator crashes. Like we've all done tests where you run it again and magically it just works, and a lot of that is to do with the performance and stability of using parallel simulator testing. So in order to figure out what exactly was, the failure rate and how we could mitigate it, we ran thousands of simulator tests on multiple machine types using the open source Firefox iOS project. The Firefox iOS app has about 200 UI tests, so it was a pretty substantially large enough app to run these tests with. So once we identified the max parallel simulators that could run without any crashes on each machine type, we then set out to optimize how we could run these simulator tests, with that in mind, to get the maximum out of the hardware that we had. So to do this, I leveraged a feature of Bitrise called Fanout builds. So so yeah, what is a Fanout build? A build that is triggered by other builds, right? So you can think of this as like, you have your initial pipeline come in and it gets to a point where it's built its artifacts, and then it wants to fan out to multiple other tasks that can run in parallel. And we call this a fan out because it basically fans out to multiple. And the idea is after the fan out builds are complete, it will then collapse back into that single primary, and then we can leverage the results of those builds. So why are fan out builds important? They really help to speed up your builds. So, if you've got a lot of sequential tasks that you're running, maybe code coverage, UI testing, unit testing, all of these things can actually happen independently. And that's because, we build the app once and then we run these subsequent tasks on those build artifacts. So what can you do with a fan out build? So there's a couple of options. What I'm going to focus on today is this first use case. So simulator testing. So, the main task here was to take, very long running tests that could take, 90 minutes, and split those up to run in parallel so that we can complete those tasks in a fraction of the time. But you can also mix and match it with other additional options. So things like unit testing, code coverage, linting. You can even build different variants or flavors of your application as well in parallel, so that you can speed up those test times. So I'm going to show you a quick demo of what a fan out workflow looks like. So let me share my screen. So yeah, so this is a primary build here, and this primary build has actually kicked off 6 parallel workflows. So you can see here that the primary build took 4 minutes and 48 seconds. And then each of these workflows took around 2 minutes. Oh, sorry, this is here, yeah. So it took 6 minutes, 45 seconds. And then these ones took about 2 minutes each. And then I also have a comparison where there was no fan out. Now, this is a pretty trivial example where the tests being run, there's only 3 tests in the test suite. So there's not a huge amount of testing being done. But just to show, this one takes 8 minutes without that fan out. And you can see the results here in the test reports add-on. So you can see here all the tests have come back from each of the workflows and are viewable in a single location. So to do this, we have a typical standard Bitrise workflow. If you're not familiar with Bitrise, a workflow is basically your build pipeline. And each one of these is a step. So this is like a sequential step in your workflow. So we're going to clone the repository, install our Cocoa pods, and then we do a build for testing. So what's interesting about the build for testing is that, when you use the xcodebuild command and build for testing, you can reuse those artifacts then just to test the application. So you don't need to rebuild it multiple times. And then we're going to compress that bundle, push it to the cache, and then we're going to use this Bitrise start build step. So this will kick off 6 separate workflows. And you can see here I've got multiple workflows here. So each one of those is going to get kicked off in parallel. Now, while the workflow is happening, you have an opportunity while you're waiting to do other work, right? So in here, you could, also test your app. You could do code coverage, linting, installing dependencies that you're going to use later. There's really just a lot of options, and you can save a lot of time by leveraging that wait period. So then the wait for build step will basically wait on those router started build slugs. So this just means, hey, when these 6 steps are finished, this step will continue. So once it continues, then what we're going to use is the Bitrise collect artifact step. Now, this is a pre-release step, so it's available for my own repo. So we'll make this available like the other steps pretty soon. So once that collects all the artifacts back using the Bitrise API, then we can basically convert those artifacts using a tool called Trainer. So Trainer will convert the XE test results into JUnit XML. And when we deploy that to Bitrise, that will make them available as build artifacts. So each of the fan out has a single XE test result, and then the test reports here will basically make those available all in the same place. Cool. So that's how you do it in a very simple manner. Now, I've also been working on a way to automatically generate your test plans. So if you have an Xcode project that uses test targets, you need a way to split these tests between multiple fanouts. So what we've done is we've created a way to go in, look at your Xcode project, and pull out these tests and basically auto-generate test plans for them. So with that in mind, this Bitrise test plan sharder will basically go in, look at it, and here I've specified 2 test shards. So it's created 2 test plans, and it's split them evenly between them. And you can see here the test plans that it generates just there. So the test plans are basically a bit of JSON, and you can leverage this inside your Xcode project and also your scheme. So it updates all of the required dependencies. So when this runs, you end up with something like this, where you can see, there was 1 test in this and there was 2 tests in that. And this all happens without any need to change your Xcode project, your test target. It's just pretty smart that it will pull all this out. To show you a little bit about that, so this is the test plan sharder. You tell it where your source is, where your Xcode project is, which test target you want to shard, the Xcode scheme where these test plans will end up, and how many test plans you want to create, and then if it's a Swift or an EMP file. So if you've got 10,000 tests and you want to split it into 1,000 a chunk, you can do that. Okay, cool. So getting back to the presentation, and is there any questions here? Let me just take a quick look. Okay. So does every test workflow need to clone repo install? No. So the beauty of sharing the build artifacts means that you can send over the derived data, but you also need to send a couple of other things with that. And I can actually show you that right now. So in my workflow where I do this cache push, so I'm actually going to send a derived data, but I also need to send my application that I'm going to test. And there's actually two apps here that we're going to test. And I also need my workspace and my Xcode project. And the reason I need these is that these are parameters to the xcodebuild command. So if I take a look at one of our test commands, we're going to unzip the derived data, and then we're going to do a test without building. And you can see here we need the XC results, we need the XC workspace. So each of these things becomes available then for the Fanout builds to actually leverage that pre-built data. Okay, and then just getting back to the questions. Okay, that's done. Show one of the fan. Okay, so I just showed that there. I think that was pretty self-explanatory, but I can go back at the end if you want to revisit that. And another question: do you have an Android equivalent? We haven't started on Android yet, so that's basically going to be our next task, and hopefully we can speed up your Android builds as well. Okay. So this export code coverage. Yeah, so there is an option to enable code coverage to be exported in the test plan. So I haven't enabled that or exposed that, but that's something I can definitely add. It should just be a Boolean that we can add to the test plan sharder to enable that. Does the sharder also work with Firebase TestLab UI testing? So for Firebase TestLab, you can actually leverage an open source project called Flank. And what Flank will do is it will shard your tests for you, and then they'll be run on real devices. So what we're doing here is primarily for running on simulators, but you could leverage it, I guess, to some extent on Firebase if you wanted. But I think Flank is a more established real device testing sharder that you can definitely use. Both Swift and M class file sharding. Yeah, so you might actually need two steps in this case. So you would need to shard your target with your Swift cases and your target with your Objective-C cases. Rolling builds and auto aborting. Yeah, so this is definitely something that has to be considered. Right now, as far as I know, we won't kill a Fanout build if the primary is aborted, but we do have a feature in progress to enable that. Will this make it possible to have a parallelization of iOS and Android builds for React Native apps? How do each builds have access to the project? Yeah, so this really depends on how you set up your React Native app, but it's definitely something that we can investigate further. Where the tests run, Firebase TestLab or simulator? Yeah, so these tests are all running in Bitrise's VMs. So you're basically fanning out and running additional builds. So your initial build will trigger two builds, and those two builds will run in parallel, and then they'll come back to the original primary build. Okay, I think two more questions here. Test suite has 10 tests in it, and 2 of the tests failed in the execution. Do we have the option to rerun only failed tests instead of the entire test suite? Yeah, this could be achieved using the Bitrise API. So if you wanted to do a retry mechanism, that's definitely possible. How you start several builds? I tried that in the trigger menu, but there I could only select one workflow per GitHub branch. That's something that I have to set up secrets, which confused me. Yeah, I'm not 100% sure what the question is there, but you should be able to start multiple workflows, one per line, with the Bitrise start build step. Okay. Too intense sharding will probably slow down the entire thing. What is a good factor for sharding? Yeah, I'm actually going to get to that next, so we can probably move on. Pre-boot the simulator to fasten the build. Yes, that's actually something that I've suggested. So like a boot script where you can warm up the simulator. It's not available yet, but it's definitely something we're looking at. Share the setup of the workflows in the YAML. Yeah, I'm going to share all the code so you can get this up and running in your account afterwards. And yeah, you'll get all the documentation, all the code, and a blog post at the end of the webinar. And possible parallelized detox tests. I'm not 100% sure. I'll check with our Android specialist about that. But I think that's it for questions. I'm going to get back to the task at hand. Okay, cool. So that was the Fanout workflow demo. And thanks for all your questions. They were super useful. Okay, so how many Fanout builds you use? So this kind of, gets back to the question about, if we fan out to too many, we're going to run slower, right? Because, there's an overhead of kicking off the build and, getting the cache data. And then also, the simulator takes maybe 45 seconds to boot up. So you've got about a minute hit every time you start up a fan out. Now that's a minute across all fan outs, so they happen at the same time. So let's take a quick look then at a fan out calculator that I created. Yeah, we're going to share this calculator so you can also leverage it. So basically, the idea is you want to put in your total build time. So here I have a 40-minute build time, and currently I'm using 4 concurrencies, right? So the idea here is to identify, what your current build time is, what your current concurrency is, because when you fan out and your builds speed up, you actually have a higher throughput. So although you're fanning out to more concurrencies, which require more concurrencies, you're also saving more concurrencies because your builds are faster. The busy wait time. So this is basically what determines how much work you can do while you're waiting for the work or for the fan outs to finish. So you can see this here in the primary, where it actually installs trainer. So there's obviously a lot more you can do here. You can even run one of your UI tests during this time, but you just have to make sure that you run the right amount of work here, because if the work you run here is longer than your fan out, then you're going to be waiting for this work to finish. And then alternatively, if you don't do any work here, then you're going to be not leveraging that time that you could have. And then the total test time. So let's say you have a 40-minute build time and a 20-minute test time, and then a 1-minute boot up. So what you can see here is basically, for each fan out, how long will that fan out take to run the tests? What will be the reduced build time? How much time will be saved? And the concurrency load. So what's interesting about the concurrency load is that, when you speed up from 40 minutes to 21 minutes, your concurrency load goes from 4 to 2.1 concurrencies, right? Because you're able to complete your builds faster and then free up those concurrencies. But you have the additional overhead of 4 additional concurrencies. So then your total concurrency count basically becomes, the concurrency load plus how many fan outs plus the primary, which is +1. So that gives you that number. And you can see here when we chart this, we actually end up with a very big drop on the first fan out, and then we kind of get diminishing returns, and then we flatline. And the reason we flatline is because of the busy wait. So if the busy wait doesn't have anything to work with, then you see that we do get additional win. But when you have work to do, you save that time. So you're saving 5 minutes off the total build time here. So this is a very useful thing. So it's going to obviously be different for different scenarios. But what we found is like 4 fan outs seems to be pretty optimal. You could go to 5 to save a minute, but you're really getting less time saved per additional concurrency. So it's not one size fits all, but it's definitely something that you can use, and we'll share that calculator in the blog post as well. Okay, so getting back to the presentation. Yeah, so one of the big driving factors here was stability, right? Like what we wanted to do is we wanted to speed up tests, but not at the risk of like 1 in 10 builds failing, right? Like you can increase parallel simulators, but you're going to get randomly failing builds. So yeah, so what we wanted to do is to make sure that we found the optimal amount of parallel simulators to run on each machine type. but also to make sure when we fan out that we're not compounding any simulator instability. Because if you have a 5% failure rate and you fan out the four parallel builds, you're basically going to have an increased chance of one of those four builds now failing. So that's why we did a lot of research on stability and performance metrics. So before I do the performance stability test results, let me just check the questions. Does Bitrise test plan charter split the unit tests into the modular architecture ID for iOS project, all workspace with several Xcode projects? So at the moment, this targets one Xcode project and it targets one Xcode scheme and one target. So you've basically got the project, the target, and the scheme, and this will do it just for one of those. So if you wanted to do it for multiple, then you could use that same step multiple times and just target different targets or schemes. And I think that's it for questions. Let's go back to the presentation. Yeah, so performance and stability test results. So let me share my screen again. Okay, yeah, so this is a tool I built to basically analyze all of the builds that I was running. And you can see here we ran over 1,000 builds on our public cloud. And what this does is it leverages the Bitrise API to pull back the Bitrise build log, and then it scans the build log and detects the simulator crash. So you can see here, on our Elite, 3VM, Quad simulator tests, we had sim error true here. And you can see here the percentage of failed builds due to simulator crashes. And we had to run quite a lot, right? Like to get the Elite with 3 sims to crash 5 times, you have to run 340 builds. So that is a 1.5% failure rate, which is pretty small, but when you're compounding those with fanouts, that can increase. And then with 4 parallel simulators, we got a 5.4% failure rate. And you can see the average build time here, with 1 simulator was obviously a lot longer than, with 2, 3, and 4. But it's not a linear benefit. So it's not like suddenly adding 2 parallel simulators increases that speed. So getting back to the presentation. So we ran over 1,000 builds. These are the counts that we ran. I had to run more tests on certain configurations to actually get any failures. So that's why not all of them are 100. The plan was to run exactly 100 on all, but 1 in 100, you may miss a 1% failure rate. So that's why we ran 343 here. And then here you can see the failure rates in relation to, the standard machines, the Elite machines. 1 simulator never crashed. 2 simulators did crash on the standard machine about 6% of the time. 2 simulators never crashed on the Elite machines, after 132 runs. And this is kind of what we expected as well. And I'll get to that in a minute. So we ran 1,000 hours of tests, and that's a lot of tests. The average build length for each of the different parallel simulator counts is shown here. So you can see that, when you move from a single simulator to a double simulator, you actually get quite a big drop on the Elite machines, but not so much on the standard machines. And that's because of the resources available to those simulators. The more you add, the more they need. And, if you don't add enough RAM or CPUs, then you're not going to get those speed benefits. And you can see here, we nearly cut the time in half with 4 simulators on the Elite machines. So from 71 to 34 was basically, took half the length of time. So it's not like you can run 4 and suddenly run in 25% of the time. It's just not a linear speed improvement. So why VM size matters? Simulators need a physical core. I'm not sure the underlying implementation of the iOS simulator, but it really benefits from a full physical core available to it to run its tests. And then it needs about 4 gigabytes of RAM. Now, 4 gigabytes of RAM is what we needed for the Firefox iOS unit tests or UI tests. But if you have, much bigger app, maybe 10 times bigger app with 10 times more tests, then maybe 4 gigs of RAM mightn't be enough for you. So it's not one size fits all. It's really just, the more resources you have available, the more simulators you can run in parallel on each build. Yeah, so the results out of all of that is basically what I showed you there. Oh yeah, here we go. So yeah, so if you want to run fast and you don't mind if like 1 in 20 builds fails, then you can have one CPU for every parallel simulator minus one, right? So you're basically saying if I want to run 3 sims, I need 2 CPUs, right? And you can run probably with 2 gigabytes of RAM. And the main reason for this is that you basically want to run fast, and if 1 in 20 builds fail, you're like, I'll just run it again, but at least most of the time my builds are running fast. And this means 3 parallel simulators on our elite machines and 2 parallel simulators on our standard machines. So if stability is super important, especially when you're fanning out because you're compounding that stability issue, you want 1 CPU for every parallel simulator, 4 gigabytes of RAM. So that's about 2 parallel simulators on elite and 1 on standard. Cool. Yeah, so the key findings there, 4 parallel simulators from what I've seen is just unstable in general. We need to run some more tests on like, a much larger machine with much more RAM to see if we can ramp up to like 5 and 6. And hopefully we'll share those results later on. Each iOS simulator does need a physical core, so I don't see any way around this. If you've got 2 cores available to yourself, you've got 2 simulators is your stability limit. And the more simulators you run in parallel, the higher your failure rate is going to be. So here's a blog post, sample code steps. We will share this as well, I think at the end of the webinar. But I'm going to jump in quickly and look at a couple of questions. Okay, can we use auto deploy the app to iTunes Connect as well? Yes, we do have a step for deploying to iTunes, and that's already available out of the box. Do you support code coverage report for Swift packages? I think so. I'm not sure if it's like tied to any sort of language. But yeah, like if you can run a script that generates a JUnit XML, then you can display that pretty easily. So yeah, there's a quick survey I wanted to run, and where is it? Yes. So yeah, so do you use iOS simulator testing? And how long do your tests take? So this is just a really quick kind of 2-question survey, just to get an idea of how many people are using it and where do they live in this kind of simulator testing. So I'll let it run for a couple of minutes and then I'll share the results. Yes, we have quite a few results coming in already. Looks like 30 minutes plus is the highest actually so far. Yes, I'll let a few more people vote. I'll just answer a couple of questions verbally here while they're filling in. Can you provide, again, the links to the example projects on GitHub? Yes, definitely. All of this will be in the blog post right at the top, so it's quick and easy to access. You can also check out my GitHub with the repositories. It's Damien Bitrise. I can actually post that in the chat so that you guys have it. And let me just send you guys a link to it. This export code coverage, yes, so that's an additional option you can enable if you want on the test plan starter. I'll probably update that today to expose that setting so that you can toggle that on and off. But I did notice it when I was creating it that there was a simple option for enable, disable it in the test plan. Okay, so we have about 30% of the survey results in. So I'm going to end the voting now. So get them in if you want. Okay, finished. And yeah, so these were the results. Yeah, so you've got basically 38 versus 9 for simulator testing, and yeah, a lot of people 10 to 20 minutes, 30 minutes plus, which is super interesting. Thanks for sharing that. Okay, so with that, let me just check what else I needed to mention. Okay, I'll answer these while you guys are taking the survey. Does this shardr also work with Firebase Test Lab? Okay, I think I answered that. What if we have both? Oh wait, I may have scrolled too far back up. Da-da-da. If test view has 10 tests in that 2 of the tests failed, for some reason I've scrolled way back up. Okay, I'm trying to get to the latest one. Okay, do you try running an iOS simulator and an Android emulator in parallel? I haven't tried that yet, but that's definitely doable. And you can do that already without any of this stuff that I've added. We've enabled execute tests in parallel on Xcode. How do we define the number of simulators? We are on the standard plan. Yeah, so there's a flag that you can actually add, which is dash parallel worker count, I think. And we have some documentation on the website. So if you want to Google that, you should find that information. And brilliant. Yeah, so I think that's it. Can these test steps be applied to an Appium for automated tests? I am not sure. I'll need to check on that. If Appium uses like an xcode build command or works with an xcode build command, then it should be possible. I just haven't tried it yet. Started now instead of half an hour ago. Was this where okay? Yeah, that was recorded. Awesome. Well, look, thanks everybody. Have a great day. Stay safe, and yeah, hope you enjoyed our webinar today.